8M4 lesson 20. Every line is a graph of a linear equation. This should be a lot of fun. This is a this is a lesson that if you get the concept, the homework is really easy, and it really solidifies that you understand the concept that graphs and equations are the same thing, and it really helps you demonstrate that you understand the concept of a y-intercept and a slope. And you can almost do the homework without any tricky, difficult calculation. It is highly conceptual, and students tend to like this lesson. This video should hopefully be relatively short, so let's get to it, and you'll see what I mean. So here we go. We're going to start with this concept first, and I've been saying this before, that a graph and an equation they're not just alike or similar, but if you have an equation like this, these become, and let's say this is the line that represents, or that, that when we graph this, when we take this equation here and we end up with this graph, these are not kind of alike. This is just a graphical representation, and this is an algebraic representation, and these are the same. These are the same thing. So when you have a linear equation, you have a line on a graph with a graphical representation, and you have this algebraic representation. These are equivalent. You can, for every point or every solution on this graph is represented in this equation, and every solution in this equation is represented in this graph. And so that's pretty cool. Some people think that these are conversions. These are the same. These are the same. And there was a guy, I'm pretty sure it was Descartes that proved this. Descartes proved that anything you can do in geometry, the study of shapes and lines and things, is the same, can be done in algebra. He made a proof that these are actually just different ways of looking at the same thing. One here with symbols and one here with kind of pictures and shapes. Kind of crazy. You don't have to understand Descartes' proof. I don't even understand it. He was very advanced, very smart. But I just want to kind of open with that observation. And now let's get to today's lesson, or the core of today's lesson, which is this. It's how do we find an equation that matches a graph? So the whole idea is I give you a graph. That's part one, or part one. And then part two is you give me an equation. The whole thing. I give you a graph. Here's the graph, and then you're going to give me an equation. All right, so that's the whole idea. Boom, boom, boom. Let's just create some more space. All right, so now here we go. So the way that you're going to give me an equation is you're going to find me the equation in y equals mx plus b form of this guy. So you need to tell me what this b is. And I put the positive in here because intercepts that are above the x-axis, like this one, are positive, and intercepts down here are negative. And so I just kind of include this sign here as we do this math. Now, then you have to tell me the slope. And the way that we're going to find the slope is using rise over run and our knowledge of what slope is. So let's just go through this example, and then you're going to do 3, and you're going to find that this is relatively straightforward stuff, but it's highly conceptual, which means if you get it, often the math and the homework becomes pretty easy. But if you conceptually don't understand what we're doing, it might be very hard. Okay, so let's see what I'm talking about. So the easy thing to find, and the reason I listed them in this order, A and B, is because this is what we usually do first. You know, it's going to be a little bit more straightforward. So let's find that y-intercept. Well, where is that y-intercept? That means, where does it cross the line? You know, where does the line cross the y-axis? And again, we learned this over the last few lessons. I'm just rewriting this to really remind you of what this y-intercept is. Where the line crosses the y-axis. It intercepts the y-axis right here at 0, 2. So our y-intercept is this 2. So our b equals a positive 2. Why positive? Because it's above. B is positive 2. Our slope. Now, our slope, we have to find our rise over our run. And the way we can do it is we can use it mathematically by saying our m is equal to y2 minus y1 over x2 minus x1. And we can use that formula. Or we can just kind of look at it visually. And if we find points that are on or on integer coordinates, like this 4, 4 and this 8, 6, we can see that our rise is 2 and our run is 4. So our m is equal to our rise over our run. I always write this out so I never get confused. Our rise is 2. We go up 2. I'll put a positive there. And our run is plus 4. And we always have to simplify our slope, and so we get 1/2. So our equation is simply y equals 1/2 x plus 2, and we're done. We are totally done. And that's it. There's nothing more to these problems. And the homework should be relatively straightforward if you understand this concept. There's one little twist I'm going to show you on the next problem, and we're going to do for the final 3 problems, which is our homework help. And we're going to also have to convert this into a different form as well. We're going to have 2 answers to our question, but I'll show you that on the next slide. Okay? So what I want you to do on this next slide, and this one is, I'm going to label this one homework help, because it is. Our homework's going to be a lot like this. We're going to find the equation of this line, and I want you to pause and try it, and then we're going to look at this part B over here, which is how to convert our answer into standard form. And we've looked at standard form before, but we might not have given all the rules about it. So this is going to be a learning. We're going to learn over here, but we're going to hold that. All I want you to do right now is just do this. Okay, find your b, find your slope, and then write your answer. Okay, so now I assume you've paused and tried. So let's find our b. Well, our b is right here. This is the spot. This is our y-intercept, which is 0, -3. So our b is -3. And now our rise over our run, let's see, let's find a point. We have this point 2, 5. So we can count our rise, which is this. Our rise is 1, 2, 3, 4, 5, 6, 7, 8, +8, because we're going up. And then we run 2. So we rise 8 and we run 2, and that's the same thing as 4 over 1, which is equal to 4. So if our b is -3 and our m is 4, we get y equals 4x minus 3. Right? Y equals mx plus b. And I'll just do all this math for you right now. So y equals 4x plus -3, which is equal to 4x minus 3. Now, the second thing that we need to do here is we got to do this, convert our answer into standard form. And those are equations that look like this. And we did this earlier in the lesson. And almost all of the equations that were given to you were in this form. So the idea is we want to get our variables on the left and we want to get our constants on the right. So here, when we have this y equals 4x plus, or 4x, I'll write it again here, y equals 4x minus 3. We already have our y on the left, but we have to get this 4x onto the left. And then our negative 3 can stay over here on the right. Right? We want to get our variables on the left. So let's do that. So y equals 4x minus 3. So we subtract 4x, and we get negative 4x plus y equals negative 3. So that's our first step. Our constant is on the right, so we're okay with that. A, B, C are all integers, so we have integer, which is a hidden 1, and we have a negative 3. All integers, we're good, but A has to be positive. So if you end up with our A being negative 4, we have to multiply both sides by negative 1. And that's how we're going to make our A be positive. So then we get, after we multiply by negative 1, we flip our signs, 4x minus y equals 3. And that's our equation in standard form. So we have two answers to the equation. One, our y equals mx plus b. Our slope intercept form, this is called slope intercept form, and we learned that last time because it's given in terms of our slope and our intercept. And this is called our standard form, where we have our x's and y's on the same side and our number on the right. This is a harder to graph form, but it's used for other purposes. Okay, so let's lay down our happy cat, happy cow. Oh, how did it switch to cows? Happy cat, happy cat, happy cat, happy cat. Let's move on to the next problem. And I want you to do both of these yourself. Okay, so we're going to do this one. How about let's do it in green, dark green. Okay, so pause and try. And again, shouldn't be that tricky from the math perspective. Highly conceptual though. So let's make sure we draw our rise and our run correctly. Okay, our B is this guy. It's given to us. Positive 3. Now our M, we can use this point, we can use any 2 points, remember, to calculate our rise and our run. Let's use maybe these 2 points. So I'll use this one and this one. But if you use any 2 points, it should work out the same. So here's our rise and here's our run. Our rise is, well, we're not rising, we're falling. So this is negative 3, and we run a positive 6. So our M is negative 3 over positive 6, and that simplifies down to negative 1/2. So our answer is y equals negative 1/2 x plus 3. Now that is our slope intercept form. Now we have to convert that into standard form. So let's do that now. So we want to put our y equals negative 1/2 x plus 3. We're going to add negative 1/2 x to both sides. Sorry, add 1/2 x to both sides. Pardon me. And so we get 1/2 x plus y equals 3. Now we have a problem here with, now we got A, variables on left, the constants on the right. Our A, B, and C are not integers. So what do we have to do to make this be an integer? Well, let's look at our coefficients here, or sorry, our denominators, and we have a 2. So what we could do is we could multiply every term by 2. We could double both sides, and that will fix the problem. So let's watch what happens when we multiply both sides by this denominator here. Right? I chose to multiply by 2 because I have a 2 in the denominator. So if I take 2, remember it's distributive, so 2 times 1/2 is just 1, so I get x right? 2 times a half equals 2 over 1 times 1 over 2. Cancel, cancel, 1, 1 equals 1 over 1, which equals 1. So we get 1x plus 2y, because we have to distribute our 2 to every term, equals 6. So we get x, because we can drop the 1, that's just implied, plus 2y equals 6. And our a is positive, so we're done. Good. Happy cat? Happy cat. All right, finally, one more, and then we're done. So pause plus try, and this will be it. I assume you're back. Here we got 0, -4. So our b is -4. Our m, see, we rise 4. We run 3. So our m is +4 over +3 equals 4 over 3. So our answer is y equals 4/3 x minus 4. Now we have to convert that into standard form. So y equals 4/3 x minus 4. We're going to subtract 4/3 x from both sides. And we get -4/3 x plus y equals -4. Variables on the left, constants on the right. A, B, and C are not integers, so we have to multiply left and right by what number? Right, our denominator. So we get, I'm going to do my multiplication over here. We get -4x, because -4/3 times 3, if you write it out, do the math, is -4, plus 3y equals -12. Now we have a problem here because our a is not positive, so we have to multiply both sides by -1 to make our a be positive, and we get 4x minus 3y equals 12. And that is our answer in standard form. So if you got these right, happy cat to you. Good work. Hopefully this was helpful. I did go, this was a shorter lesson than normal. I think that these concepts are perhaps easier. The homework is shorter. I went through 3 examples. There's a lot of examples you get on your homework. They work exactly the way we did in class. Just find your b, find your slope, write your equation, convert your equation to standard form if the homework asks you to do it, and you're done. So graphs are lines, lines are graphs. Graphs can be, all linear graphs can be written as a algebraic equation. And that's what we learned today. Very powerful and great conceptual understanding if you got it. Hopefully you did. Hopefully I was a good teacher today. See you next time when we do lesson 21, probably more linear equations, and happy math.